Have you ever looked up at the night sky and felt a profound sense of wonder? A feeling that you're staring into an abyss of beautiful, humbling, and sometimes terrifying mystery. That feeling compels us to look beyond the stars. For as many mysteries spark our curiosity here on Earth, mysteries out in the cosmos continue to plague the greatest minds in human history. It's what drives us to build bigger telescopes, to devise more elegant equations, and to ask ever deeper questions about our cosmic home. The universe, in its endless mystery, seems to delight in presenting us with puzzles that stretch the very limits of our imagination and our understanding. It's a cosmic game of hide and seek, and we, humanity, are the seekers, piecing together the clues left behind in starlight and gravity. Welcome to Pocket Astronomy Facts and our Cosmic Top 5 series. And today, we're diving headfirst into the deepest, most perplexing enigmas of the cosmos. We're counting down the 5 biggest mysteries of the universe and why they still baffle scientists today. We'll explore the invisible scaffolding of the cosmos, the mysterious force tearing it apart, and the places where our most fundamental laws of physics simply break down. First, let's start with what's missing. When we look at a galaxy, we see stars, gas, dust, all swirling in a magnificent celestial dance. We can measure their speed, we can calculate their mass, we can apply Newton's laws of gravity to predict how they should behave. But there's a problem, a huge one. The outer stars of galaxies are spinning far too fast. Based on the visible matter we can account for, they should be flinging themselves out into the void. The gravitational glue just isn't strong enough. It's as if an unseen hand is holding it all together, adding immense gravitational pull. This invisible substance, this cosmic ghost, is what we call dark matter. It makes up a staggering 27% of the entire universe, yet it emits no light, no heat, no radiation of any kind that our instruments can detect. It's completely invisible to our telescopes. We only know it's there because we can feel its gravitational tug on everything we can see. Is it a new kind of subatomic particle? Something beyond our standard model of physics? Is it a collection of primordial black holes? Or is it something so profoundly alien that we haven't even conceived of it yet? The truth remains shrouded in darkness, literally. But if dark matter is the universe's invisible glue, then our next mystery is its cosmic accelerator. For most of the 20th century, we thought the expansion of the universe, which began with the Big Bang, must be slowing down. Gravity, after all, pulls things together. But in 1998, astronomers studying distant supernovae discovered something that shocked the entire scientific community to its core. The expansion isn't slowing down, it's speeding up. Something is actively pushing the universe apart, working against gravity on the largest scales. We call this mysterious repulsive force dark energy. And if you thought dark matter's share of the universe was big, dark energy is the undisputed heavyweight champion, accounting for roughly 68% of the total energy density of the cosmos. Think about that. All the stars, galaxies, planets, and people, all the normal matter we've ever known, make up less than 5% of reality. The vast majority of the universe is composed of these 2 dark components we can't see and don't understand. Dark energy is as if space itself has an inherent, ever-increasing pressure, pushing everything away from everything else. But there's another mystery that you may have heard about, one that doesn't push things away, but sucks them in. Its force is so strong, nothing can escape. Yup, we're talking about black holes. We understand their formation. A massive star collapses under its own gravity, compressing an immense amount of matter into an infinitesimally small space. This creates a gravitational field so powerful that nothing, not even light, can escape. But what happens at the very heart of a black hole? Einstein's general relativity says all that matter is crushed into a point of zero volume and infinite density, a singularity. Here, at this single point, our understanding of the universe completely and utterly fails. The laws of physics, as we understand them, cease to make sense. General relativity works beautifully for the large and massive, while quantum mechanics perfectly describes the world of the very small. But inside a black hole, you have an immense mass crushed into a quantum-sized point. The two great pillars of modern physics collide, and they cannot be reconciled. A singularity isn't a physical object. It's a declaration of ignorance. It's a flashing red light telling us that we need a new, deeper theory, a quantum theory of gravity. But as these mysterious cosmic vacuums move about space, our own galaxy, the Milky Way, isn't sitting still either. We are hurtling through space at a staggering 1.4 million miles per hour. Relative to the background radiation of the universe, we're not just moving, we are being pulled. Our entire local group of galaxies, including Andromeda and even the larger Virgo supercluster, are all being drawn toward a specific, unseen point in the cosmos. This gravitational focal point is known by a name as intriguing as the mystery itself, the Great Attractor. It's an immense concentration of mass, exerting a powerful gravitational influence across hundreds of millions of light years. The problem is, we can't see it. The Great Attractor lies behind the dense plane of our own galaxy, a zone of avoidance. While astronomers use X-ray and radio telescopes to peer through some of the haze, a complete picture still remains elusive. Is it a massive supercluster, a titanic filament of dark matter, or something even scarier than that? No one really knows as of now. Astronomers comb the night sky looking for clues all the time. Some of our searches takes us back to the very beginning, to the first, unimaginably small fraction of a second after the Big Bang. According to our best models, the universe underwent a period of exponential expansion known as cosmic inflation. It grew from smaller than an atom to larger than a galaxy in less than a trillionth of a second, expanding far faster than the speed of light. The mechanism that triggered and ended this inflationary burst remains unknown. No particle or field predicted by physics fully accounts for it. We simply just don't know how, why, or what caused this to occur. And the truth is, we may never know. The universe has existed long before we had super fancy telescopes to look out at what's around us. Which means, on a larger scale, we're practically infants learning how to walk when it comes to our understanding of the universe. As we have answered some questions that confused the minds of our ancestors, perhaps our future descendants will have the ability to find out exactly what is behind these mysteries and many more. But for now, our imagination, combined with science, is our guide. And just like our imagination, the possibilities in the universe are endless. Thanks for watching this episode of our Cosmic Top 5 series. Keep an eye out for the next episode, subscribe to the channel if you're new, and we'll see you next time. Take care.